Okay, so the last unit of this C++ is a template and standard template library. So we will see what is template and what are the ready-made template library classes are available. So first is what is template, right? So in unit 1, in slide number 72, we have seen the function template. So that is nothing but a generic function description. So what is use of function template? So the use of function template is once you write a definition of any function as a function template, so that function treated as a generic function, and generic function means for that function whatever parameters you passed as argument, the type of those argument is any type. That means you can pass any type of data to those arguments. Okay, so that function will work for any type of data. So it is nothing but a generic function. So it may be work for the primitive data type or it may work for the user defined data types. So the sequence of argument is important. Uh, the data type in that case is not important. Data type is a generic, that means it is a wider data type. So any data type can accept uh, into that function. So this is nothing but a function template, and basically this concept is known as a generic programming concept. So generic programming concept is useful when you write once your definition of the class or function, and that will work for in future for any user defined or primitive data type. So only one definition will work for any data type. So basically that is the main advantage of generic programming. It is a feature of generic programming. So for example, suppose you write a stack, user defined stack, and once you write that stack, that is a push and pop operations of a stack, and that stack will, suppose initially it is working for only integer data type, and suppose next time I want to store a string data into the stack. So what you will do, so you have to write another class for stack and who takes the string argument into the stack. After that, suppose I want to store the float or double. So again, in that case, you have to go again float or double data type. So we are writing the separate definitions for the separate if you want to hold the data into the stack. So better approach is you write only once as a stack definition, and that is a class. That class should be the generic class. Now to write a generic class in C++ is using the class template. So we can write the function as well as class as a form of template, which can work for any kind of data type. So this example of the class stack is given. So for example, how to write the user defined stack. So I will show you. So look in this slide, example is visible to you, right? So in line number 1, it's just an header declaration with the namespace std. Then we are having line number 4 is important. So how we write the template for function template. So here also you have to write it template and then type name t. So the class template, that this stack can work for the type t, and t means any data type. Okay. Now, so in this case, in a class stack, so it is user defined class. So private data members are declared. The t was, what is t? Is a t is nothing but a data type. So it may be any data type. It may be the integer. It may be the character. It may be any user defined data type. That is a class, student class, suppose, or employee class. So t may be anything. Hello, who is CB? Please mute yourself.
37 भागिले 10 फॅक्टोरियल 27 फॅक्टोरियल इकडे आणि इकडे राहील 10
Chetan,
फॅक्टोरियल
Mr. Chetan. Okay. Okay. So T is any type of array and it is a pointer variable. So we want to create the array dynamically. Now, line number 7, 8, and 9. Just look. 7 is declaration of an array pointer variable. 8 number is a constant variable. This is a size. And if you declare a data member as a constant variable, so in that case you have to initialize that as a class member, initialize that variable into the class member list. So member initializer list is in front of the constructor, and then you have an integer tops, that is a top for the stack. Now go to the public data members. So that is a constructor. So stack parameterized constructor having integer size, and that size is initialized. Look how the constant data members are initialized inside the parameter in front of the parameterized constructor. So look what are the different ways we can write in front of the member initializer list, inside the member initializer list. So we can call the superclass constructor explicitly in inheritance, right? We can assign the object to the um, another object which is available in a composition. So this is second use. Here third use of member initializer list, we can initialize the constant data member. So size into bracket size. So what is capital size is the name of the data member, and that small size is the name of the formal argument which is available in your parameterized constructor. And now in a parameterized constructor, the array is initialized arr is equal to new t size, right? So dynamic memory is allocated for that array, and then top is initialized to the -1. Then we have a push operation and the pop operation. In a pop operation, we have to retrieve the topmost element, and the when you return it topmost element, the return type of the that member is nothing but a t. T means any type, so it will work for any element. Similarly, when you push the element into the stack, that element type is also again a t. It may be any element, right? So it's a generic stack, so we created. Okay, so up to the line number 24, it's a generic stack definition is available. Now what is the use of that stack? So whatever we stack is created, what is use of this? So line number 25, just look at in a main function we created now object of stack. Now how to create an object of stack, this is important. So generic class, when you create any object of generic class, so we have to mention now data type, which data type you want to store into that stack at the time of object creation. So in that case the compiler will treat your template for that data type. So when you create a stack, look in angular brackets, it is integer int, and then object is created normally how the object is created for your normal class. So s1 is object, and in a bracket you pass to 5. So what is 5? 5 is basically a size of the array, right? S1. In that case, parameterized constructor gets called for the stack class, so it will jump to your parameterized constructor of stack, and the array is initialized for size 5. It is for a t data type, and the top is initialized to -1. And then s1 dot push is called, the 10 is passed, s1 dot push 20 is passed. So s1 object now it will work for integer. Okay, so s1 object stack will work for int data type, and then we can use a pop also, s1 dot pop. Similar stack, suppose I want to use for character data type, then I created a s2 object. Now in line number 32, line number 32, how, look how the object is created. Hello. So how the object is created? Stack angular bracket character, it's a char, and s2 is equal to, now you are passing 10. So what is that 10? 10 is nothing but a size of an your array, and then we are pushing the element a b c d. So now your stack will work for character data type. Now s1 and s2 are the two objects for the same class, but now data types are different for s1 object and s2 object. That means for a stack, so one s1 is working for the integer data type and s2 is working for the character data type. So for two objects, two different data types, the class definition is a single, and that is possible because of your class template. Is it okay? So this is user defined class template. So if user is required to create the our user defined class template, then you can create it. And suppose you want to use the ready-made class templates, it is known as a standard template library. That library is available inside the C++, and that we can use it. It is known as STL, it's a standard template library. So next point is standard template library is nothing but the is important feature of C++ in recent year. That means in latest versions it is available. The STL was the one of the major efforts that took place during the C++ standardization, and it provides a general purpose templatized classes and functions that implement many popular and common used algorithms, that is a data structure algorithms most of the time. And it supports the your vectors, linked list, queues, and stacks. Okay. It also defines the various routines that accesses them, and because of the STL is constructed from the template classes, the algorithm and data structure can be applied to any data type, nearly any data type. Now look here. Uh, so first, the STL is a complex piece of software engineering that uses some of C++ most sophisticated features, and just to wait. Okay. So now STL is a complex piece of software engineering that uses the sum of the C++ most sophisticated features. To understand and use the STL, you must have to complete understanding of C++ language, and including the pointer and references. And that main concept is templates. At the core of standard template library are the three fundamental, you can say, or foundational items. These are, one is container algorithm, iterator. That means your STL library, standard template library, is having three important categories. First is container, second is algorithm, and third is iterator. So what is container? So basically container which holds your data. Algorithm who applies the applies on data. That means it is operation on data. An iterator that how we retrieve the elements from your container. So it is iterator. So how we iterate the elements is using loops and different things. Okay. So three important concepts for your standard template library we have to understand. So first is container. What is container? So container are the objects that hold other objects. So it's one object which holds two other objects, and objects may be any type. Okay. So what are the inbuilt container classes are available? So we will see. So first is bit set. Then we have a DQ, list, map, multi-map, multi-set, priority queue, queue, set, stack, vector. So what are the data structure algorithms we know uh, from the academic is we know the stack, we know the queue, right? We know the set, we know the map, we know the DQ, right? So what is a DQ? The DQ description of DQ, look, the second container is a double-ended queue. So double-ended queue. So do you know the concept of double-ended queue, right? So from the both end it works. So double-ended queue, if you want to use into your application, so we can use a container DQ. So it's a ready-made available. No need to write the DQ operations or DQ class. Only create the object of DQ, put the data and use your DQ. Okay. Similarly, stack, ready-made stack is available. Then dynamic array if you want. So vector is available. It's like a singly linked list, right? Then a linear list is available. Then map is available. Multi-set is available. Priority queue is available. Priority queue depends on the priority. It works how you set the priority to the your data. So these are the some of the containers are listed. So for example, vector is given. Okay. So suppose you want to use the vector. Vector is a dynamic array. So if we want to create our own dynamic array, then we have to go with a pointer variable and then use it, right? But here it's dynamic array ready-madely available. We have to just create an object, put a data and use it. So look at line number 2. So we are having hash include vector. So what is that vector? So this is a header is required for that container. So if you want to use a vector, we have to include the vector from the header. So this is your container, and in main function line number 8, the vector integer, the object is created VEC. So you can create any object, but now the your vector will work for integer data type because I want to work for int data type. Another one index is created integer I, and then we assign one size, vector size equal to vect dot size int. So what is the initial size of vector? We want to cross check it. And initial size of vector, if we print vec dot size, what is size? Size is now the function for that vector class, and that size function is implemented in a vector class. That's why it is applicable, and it will print a 0 initially, right? So in output window, vector size equal to 0 because there is no element available in vector. Then for loop is used. For loop I is equal to 0, I less than 5, I plus plus. So for the 5 elements, and vector dot pushback. So pushback is the function available for vector which will push the element into your array. Okay, and what element I want to push it? That is I. What is I? Initially it's a 0, then 1, 2, 3, 4 up to the 5 element. So it will store a one first initially 0, then it will again iterate, it will go to the first index, then second index, third and fourth. Why it is up to the fourth? Your for loop is up to the I less than 5. So these element will store into the vector. And then what is the size of vector? Again I will cross check after the For loop, that is in line number 19, check the extended vector size. That means after storing the element, what is the vector size? And now vector size is your phi, extended vector size, right? The extended vector size is equal to 5. That output is printed. And how to retry the element from the vector? So for I is equal to 0, I less than 5, I plus plus. And how to retry it? Vector of I. So it is working on index square bracket of I. So it will retrieve 0, 1, 2, 3, 4, whatever elements are stored. So after this for loop, again I want to store the element into the vector. Then suppose, so vector dot pushback, suppose I store a 20, then what is the size of vector? So it is a 6 now, correct? So if you want to remove it, so remove function is available. So what is pushback, size, remove? These are nothing but the algorithms on your container. Okay. So this is example of only one standard template class from the standard template library. Okay. So we can use any ready-made class from the standard template library, put a data into that and use it. Okay. This is the example of vector. Now what is algorithms? So algorithm acts as a container, acts on a container, sorry, acts on an container. Algorithm, each container provides a support for its own basic operations. And these operations may be your searching, sorting, okay, deletion. So any manipulation of the data you can do using the algorithm. In previous example, pushing the element is nothing but you are manipulating the vector, and when you are retrieving it, you are find iterating the elements, right? So algorithms, to access the STL algorithms, you must include the algorithm into your program, that is a header. And STL defines a large number of algorithms, so it's a huge list. All the algorithms are template functions, so it is generic functions. This means that they can be applied to any data type. All algorithms in the STL are the covered as a part 4. So that is uh, in the next slide. So look, what are the algorithms? So it is some of the algorithms I will tell you. So find algorithm is available. Look at find, equal, then copy, binary search is available. Okay. Then we have the adjacent find. So look, read the description. What is binary search? Performs the binary search on then ordered sequence. So if you have a list of array and you want to perform the binary search, you directly call the binary search algorithm and pass your object to the binary search. That's it. So binary search will perform, and if the items available, it will find the element. Okay. So find searches the range of value and returns an iterator to the first occurrence of the element. So every algorithm having its own advantages. So we can use it. So this is the first list. Again, it is having second list. So max is available, mean is available. Look at partition is available, partial sort is available. So depends on the requirement. We can use any of the algorithm. Max make the heap is available. Maximum element is available. Then from this list, searches the sequences, subsequences of the sequences. Sorting is available. Sort, if you want to sort the elements, how will sort it? So normally you are writing your own algorithm to sort the element, and it will only work for integer, correct? So suppose I have a string data or character data, and I want to apply the sort, ascending or descending. So in that case, we have to write our own algorithm to sort the element, character element. So in this, in you, if you are using standard template library, no need to write the sorting algorithm to sort the element. Don't worry about the any data type. Only create the list of elements, pass that array to the sort function. Sort function will sort it and it will display it. Okay, so that is the example. That is the best example how to sort the element. Now the question is which sorting algorithm is used. So we don't know it because sorting algorithm is developed. That function algorithm is developed by system developer. We have to look the source code and then find out which algorithm is used for sorting. Okay, so it will sort the element. Then swapping the element, exchanging the element, that algorithm is also available. So look, one example is given here of the algorithm. So I included the header, algorithm header, hash include algorithm. Then the array is available 158967342. So 10 elements are available. Then the size of array is uh, that is a partial size of array is removed. So size of array divided by size of array of zeroth element. So basically that is nothing but your n. Okay. So size of array is 10 elements and size of first element, zeroth element is your 4 byte. Okay. So size of array is 10 into 4 is 40. 40 divided by 40 divided by your 4, it's a nothing but a 10, correct? So total 10 elements are available. And we are passing, now we want to pass the sorting. We have to pass this array to the sorting function. So sort into bracket, we are passing array. How to pass the single dimensional array to the function? So name of the array, comma arr plus n. So what arr plus n? So we are basically passing address of the first element plus n. N is your nothing but a 10. So 0 plus whatever is your 10. 0 plus 10 is passed. This is nothing but a size of an array. The sort function will sort it and it will now store into the array. And then how to retry the array? Array after sorting, look for loop I is equal to 0, I less than n plus plus I, and then arr of I is printed. Okay, so this example is for sort the array. So within this example, it's a hardly 1 to 20 lines. So approximately the sorting is only 4 to 5 lines of code. So apart from that, there is no any sorting definition I have written in this example. There is no any specific data type is required for this example. We can sort any type of element. So you can just pass it and use it. So this approach, generic programming approach, is very important. It is again useful in the most of the programming languages like C++, Java, .NET, then Python, PHP. So generic programming is useful because it doesn't depends on any type. Okay. So if you have a doubt, you can ask me.